Yeah, okay, then maybe I'll just leave them on, because then we don't have to feel like we're in a dungeon. All right, so our lesson today is section 5.2. We're going to learn about how to multiply polynomials. But just a reminder, today is the last day to take the Unit 1 tests and also to turn in any Unit 1 assignments. So if you have any late work from 4.4 or before, make sure you get that turned in by tonight. So if multiplying polynomials, we talked yesterday about what polynomials are, as well as how to add and subtract them. And basically you just like combine like terms. And with multiplying polynomials, we'll use some of the place value stuff that we talked about last class. So first of all, if we had a monomial multiplied by a trinomial, so remember a monomial has a single term, a trinomial has 3 terms. Multiplying by monomials is super easy because it's basically just distributing. So you would say 2ab, if I multiply that times negative 3a squared, well, 2 times negative 3 is negative 6. A times 2 other a's, because remember a squared means that you have 2 a's multiplied together. So if I do a times 2 other a's, then I'm going to have a cubed. And then b times no other b's will just be b. And then I'll distribute the 2ab to the next term, which gives me. Yep, because an exponent is essentially repeated multiplication. And so if you have like several bits of repeated multiplication, then you can just figure out how many you have altogether. Yep, so we'll go 2 times negative 2 is negative 4. Then a times a will be a squared, and b times b is b squared. And then if I do 2ab times the last term, I'll get positive 14 ab cubed. So multiplying by monomials is basically just distributing. Any questions on like how I got the numbers or the exponents or anything like that? Okay, so that's how you multiply a monomial. But sometimes you might have 2 binomials multiplied together. So you might have heard of FOIL, which I'll explain in just a second, but I want to explain the reasoning behind it first. So if you have these 2 polynomials multiplied by each other, you just have to make sure that each term gets multiplied by all of the other terms in the other polynomial. So I like to do this just kind of methodically, and I'll say, well, 2x times 6x will give me 12x squared. 2x times negative 7 gives me negative 14x. So I've distributed the 2x to both of the other terms, but I also have to distribute the 5. So I'm going to distribute 5 to 6x, which gives me 30x, and 5 times negative 7 is negative 35. And then you can simplify this because these terms both have x's, so you can combine them. And if I have negative 14x's plus 30x's, I think that should give me 16 x's. Sweet. So that would be the multiplication of those 2 polynomials. So if you have learned about FOIL before, FOIL is basically like just a little algorithm to help people remember this. So the S stands for multiplying the first term. So that would be that. You multiply the first term in each binomial. And then the inner ones are where you multiply the 2 inner terms. The outer ones would be multiplying these 2, and the last would be multiplying those. So FOIL is helpful if you have 2 binomials and you like the algorithm, but basically what it's having you do is just remember to distribute everything to all of the terms. And it's not very helpful when you have a problem like this one, because in this one, it's like, well, which one's the inner one? Which one's the outer one? And you actually have more steps than just doing 4 things. So I don't personally like using FOIL because it only applies if you have 2 binomials, but if you have if you have polynomials with more terms, then it doesn't work in those situations. So when you have more variables involved, you would basically take the 5x squared and distribute it to both. And then you take the negative 2x, distribute it to both, and then take the 6 and distribute that to both.
Okay.
So you'd have like 6 steps. And like if you had 4 terms, then you'd have to. Yeah, so basically the main thing is you just need to make sure you distribute everything to everything else. And one way that I really like to do multiplication, especially with big polynomials like this, is to use the place value method. So you can do it just by distributing, and if you like that, you're welcome to do that. Another possibility though, is to use that place value method I was talking about last class, where instead of having like a ones, a tens, and a hundreds column, you have a constant, an x squared, x cubed, etc. So I could write this polynomial in my place value columns like this, and then I would have 3x minus 9. And I want to multiply these two polynomials together. And the process for multiplying these two polynomials together would be the same process as if you were multiplying like 248 times 37 or something. Because if you were multiplying just regular numbers, the way that you would do it is you would do 7 times 8, 7 times 4, 7 times 2. And then you do 3 times 8, 3 times 4, 3 times 2, right? Everybody good with that from, I think it's like 4th grade or something, whenever you learn that. So with polynomials, you basically do the same thing and you'd say, well, -9 times 6 is -54. -9 times -2 is +18. And sorry, I should have included the x. So -9 times -2x would be +18x. And then -9 times 5x squared would be -45x squared. And then you'd take the 3x and you'd say 3x times 6 is 18x. 3x times -2x is -6x squared. And 3x times 5x squared is 15x cubed. And then you could, one of the benefits of doing it this way is that the like terms automatically get lined up in the same place value columns. And so you would end up with 15x cubed minus 51x squared plus 36x minus 54. And it doesn't matter whether you use the place value method or if you just do the repeated distributing thing, because you end up with the same numbers. Like if you did 5x squared times 3x, well, that's the 15x cubed. If you do 5x squared times -9, that's the -45x squared. If you do -2x times 3x, that's the -6x squared. If you do -2x times -9, that's the +18x. 6 times 3x, that's 18. 6 times -9 is -54. So this method of putting them in like a place value chart is just to help you remember to multiply all of them, because you're probably relatively familiar with doing regular like number multiplication. And it's also kind of nice because the like terms automatically get lined up. But the big idea is that every term in the first polynomial has to be multiplied by every term in the second polynomial. Any questions on that so far? Okay. Can you guys show me on a scale of 1 to 5 how you're feeling about multiplying? Okay. So I'm just curious. So there's kind of like 2 different methods I taught you. There's the repeated distributing method or the place value method. How many of you guys prefer this one, the repeated distributing? Okay, cool. And how many of you guys prefer this one? Okay, awesome. So I'll probably do the repeated distributing since most people like that one, but you can totally use this one if that's the one that makes the most sense to you. All right, so on your homework, there's 2 questions and I wanted to just highlight the difference between them. So in one of the questions, it says let A equal 2 and B equal 3 and evaluate each of these expressions. When it asks you to evaluate something, your answers are going to be numbers. Because essentially what you're doing is you're taking 2 and plugging it in for A, taking 3 and plugging it in for B, and simplifying it down to a single number. Versus on another problem, you're given 2 polynomials. So they say the polynomial P with an input of x is 3x minus 4, and Q of x is 5x minus 4. And then they ask you to subtract the polynomials, add the polynomials, and multiply the polynomials. And in those situations, you're just simplifying it, but your answers are going to have x's in them. So these 2 parts will be kind of a review of what we did yesterday. And then this one will be where you apply what we learned today. and you'll multiply this polynomial by this one. So does that make sense, the difference between evaluating versus simplifying? So evaluating, you get a number because you're plugging in numbers. Simplifying, you're just simplifying it until it like doesn't have any parentheses. So to summarize what we learned, there's 3 different ways that you can think about multiplying polynomials. Sounds like most of you guys prefer the distributing method. You can also do the place value method if you like that. And then the FOIL method, I would say it's the least useful method because it only works if you have a binomial times a binomial. But if you have like trinomials or monomials or things like that, you can't use this method. And so I would recommend choosing one of these 2 when you're multiplying them. So the FOIL method is just a way of remembering the distributing method. So like when people do FOIL, they'll like say, oh, well, the first term times the first term is 12x squared. Then they'll go to the inner ones and they'll say 5 times 6x is 30x. And it's just kind of like an acronym to help them remember that. So yeah, it's basically a way to remember the distributing method, but it only works with binomials, which is why it's not very useful. Well, if you have trinomials. Yeah. So any questions on any of that we covered so far? All right. So I have 3 problems I'd like to go over with you guys. So question 10 has fractions and exponents. Question 11 has multiple polynomials we're multiplying together. And question 12 is just like kind of a combination of a bunch of things. So I'm going to start on question 10. If you guys want to pull your homework out, open up your laptops and I'll go over this one. I'm glad you guys can see it with the lights on because it's way nicer to have the lights on at the front.
I think it's so cool, so we're not sitting here in the dark, and then you come over here and suddenly turn on the lights.
And you're like, whoa, blinded. Also on the homework, there's like various like instructions, like some of them will say, use the FOIL method or use the vertical method. You can use whatever method you want on all of them. You don't have to follow the instructions on that. And actually, I have no idea what the vertical method even is. So if you look in your textbook, there might be another method you could use, but they should all give you the same result. Okay, so on this one, what are the polynomials that we're multiplying together?
Y minus.
So that's one of them. What's the other one we're multiplying? Yep, exactly. So if you see an exponent, that basically means you're multiplying this by itself this many times. So in this case, we have the same thing multiplied together twice. And I'm going to use the distributing method. And if I do y times y, that equals y squared. Y times -2/7 y equals -2/7 y. And then if I distribute the -2/7, I get -2/7 y. And a negative times a negative is a positive. And when you multiply fractions, you just multiply the top numbers and multiply the bottom numbers. So -2/7 times -2/7 will be positive 4/49. And then when you're adding and subtracting fractions together, so like in this case, since these both are y terms, I'm going to combine them by adding their coefficients. So if you're adding things together, then that means you have to have common denominators. But in this case, we already do have common denominators. And so this would simplify to be y squared minus 4/7 y plus 4/49. Because -2/7 minus 2/7 is -4/7. So multiplying, you multiply the top and the bottom. Adding or subtracting, you have to have common denominators, then you only add the top. Any questions on that one?
So say I had 4/7, so -4/7 minus 4/7, it would, the final would probably be 8/7
You said -4/7 minus 2/7?
minus 4/7.
-4/7 minus 4/7? Yeah, that'd be -8. Yep. And when you multiply them together, you get 16/49.
So when you combine the two middle terms,
No, because it's kind of like if we took the fractions out of it and you just had -2y minus 2y, you're saying I have -2y's and I have another -2y's, which means I have -4y's. Yeah. So it's like combining like terms. It's just a little more complicated because you have fractions. Okay. The next one I'll go over is question 11. So on question 11, you have to do it in a couple steps because you can only multiply two polynomials together at a time. So in this case, we have 4 polynomials multiplied together because we have a monomial, a binomial, and a binomial. And so it's kind of like if you multiply a bunch of numbers together, like if you did 1 times 3 times 5 times 8 or something. Like you'd have to go 1 times 3, then take that result, multiply that by 5, then take that result, multiply by 8. But you can also like multiply 2 of the numbers together and then multiply those results together. Kind of like if we do the regular number thing again, like if you do 1 times 3 times 5 times 8, you can either go 1 times 3, then take that result, multiply by 5, then multiply by 8, or you could go 1 times 3 is 3, 5 times 8 is 40, and then multiply those together. So I think that way is a little bit shorter, especially when you're working with polynomials. So I'm going to do that same thing here, where I take 4 times x and -3, which gives me 4x minus 12. So that's essentially multiplying both of those together to get a single polynomial. And then I'm going to take these two polynomials and multiply them together. And when I do that, I get x squared plus 2x minus x minus 2. And that's my second polynomials multiplied together. And that can actually be simplified further because 2 x's minus an x is just a positive 1x. So I can simplify that a little further. But I'm still not done multiplying because I have these two polynomials that need to be multiplied together. So I'll distribute these and I'll get 4x times x squared is 4x cubed. 4x times 1x is 4x squared. And 4x times -2 is -8x. And then -12 times x squared is -12x squared. -12 times 1x is -12x. And -12 times -2 is positive 24. And then there are some like terms there. So I think this is the only x cubed. So I'll have 4x cubed, but then 4x squared minus 12x squared is -8x squared. And then -8x and -12x will make a -20x. And I have positive 24. And so that would be the result for that multiplication. So the main idea is if you have multiple polynomials, like more than 2 multiplied together, you can only multiply 2 at a time, and then you can take those results and multiply by the other polynomials. Okay, so on question 12, this one has multiplication of polynomials inside of terms that are being added and subtracted together. So the structure here is we have 3 terms that are being added and subtracted together, but within the terms, you have multiplication in these two. And so essentially you're going to simplify each of those and then combine any like terms. So if we start off by simplifying this first term, x minus 2 squared, well, I'll just simplify that over on the side. So x minus 2 squared means I'm doing x minus 2 times x minus 2. So I'll do my repeated distributing here, which is x squared and negative 2x, and positive 4. When I combine the x's, I get x squared minus 4x plus 4. I went through that really fast. Does anyone have any questions on that? Okay, so that's that first part. So that simplifies to be x squared minus 4x plus 4. And then for this part, if I distribute a positive 3 to the x and the minus 2, I'll get plus 3x minus 6. And then I have the minus 10 for my very last term. And then some of these terms are like terms, so we could combine them. There's only one x squared, so that will just be x squared. And then negative 4x plus 3x is negative x. And 4 minus 6 is negative 2. And negative 10 is negative 12. And so that is the simplified version of this expression. So in my opinion, those are the 3 most challenging questions on your homework. So the rest of it should be pretty easy after that.